tape. Alright, so with my fourth octet being the interesting one because of my bit number that I've got.
Use the block number to figure out the subnet, right? So multiple of the block number.
Right, so basically, /27 means if I look at my calculator, 32, 16, 8, 4, 2, 1, I've got 3 bits in the 4, so 1, 2, 3.
32.
My block size is 32. So what I'm doing here is looking at, well, here's the .111. What multiple of 32 is less than or comes before and after 111? So before it would be basically .96. After it would be .128. So this is my network. This would be the next
Now,
network.
you did that fast in your head by doing multiples of 32 until you got your range to see where it falls within 2.
So these are basically, like I said before, my bookends.
So it's on the 96 network.
It's on the 96 network.
It
So
would be 146.96. That's its network.
correct. Well, the whole thing. 172,
Right.
19, 146.96.
Okay.
/27, because it means nothing without that
Right.
match.
That's your network. So now you just got to find.
The first valid address on this network to define the range would be add 1 to this. So 97 is the first address. First address is always odd.
Oh yeah.
The last, the broadcast address is 1 less than the next network address. So in this case, I just subtract 1.
And the last is 2 less than the next subnet?
Exactly. Always 2 less. In this case, 126, which the end of a valid range is always even. So my network can have hosts between .97 and .126 in the 4th octet. And then the question really was, what's the first valid host? Well, that was just
I
9.
keep screwing up because that's when we only use 2 octets instead of, I guess, you know what I mean?
Yep.
For some reason, I'm losing myself.
And I'm going to do the same address, but with a different mask, so that I have 2 of them.
Cool.
All right?
Yeah.
So that was the Class C, which is the easy ones. Because I'm just working in 1 octet, and it's, it's contiguous numbering. It's only in, 1 octet where I've got to deal with stuff. All right, so what happens if I mess up my mask here? It's no longer going to be this value. It's no longer going to be a 27. Let's say that it's a 19. Let's see, 17, yeah, 19. In this case, I'm now at 224 in the 3rd octet and a 0 in the 4th in my mask format. And this stuff doesn't mean anything anymore. Because my now interesting octet happens to be the 3rd octet. My /19 says that bit falls somewhere in here, so this is where I've got to do my work. So with a /19, I've got 16 bits in the first 2, so 17, 18, 19. Yes, I use 32 for a reason, because I've already worked with this one. So if I am the .146.111, and write out both octets, because you need to start wherever my interesting bit may be, where it changes from, network to host. The rest of that I need. So what is the network before and after? Well, in this case, it's again multiples of 32, but in the 3rd octet. So my beginning is going to be 128.0, and the next one will be the 160.0. So this is my subnet, and this is the next subnet. So if asked what network is this address a part of? Well, it's on the 172.19.128.0/19 subnet. Now to find out the first valid host on that network, I go to the end and just add 1. So 128.1 is my first valid host.
And the next 2 spots, for some reason, I keep screwing up on it.
This is where you get messed up,
I don't
right?
know why.
So what you do here is you subtract 1 from this number,
Okay, that's for your forecast.
159, and then because it's a broadcast, even if I had 2 octets left, it doesn't matter. For the rest of the octets, you make them 255.
Okay. Next.
And then for the next one, you keep this number, and you subtract 1 from this one.
That's where I'm screwing up.
And that's the last valid.
This one on this octet that I did
Wait.
on 4th.
So this is my valid range for this network, 128.1 through 159.254. Now, How many addresses is that?
You subtracted from the, you always subtract from the last octet? Is that like a rule? Like for your last address? You went from 159
because it's one less than the broadcast.
Okay.
Hmm?
So the only...
Okay, and now the,
Minus.
now the 2 to the n power minus 2, right?
Yep, because my mask is a 19, I can determine the number of hosts. Basically, it's a 32-bit address, but 19 of those bits belong to the network. So how many are left for the host? Do your subtraction, and I've got 13 bits. 2 to the 13th minus 2, which means I've got 8,190 hosts on that network.
Awesome.
So you're using the new mask, well, whatever mask we found out to be valid. Subtracting out from 32-bit, minus 2 to that power, and then minus 2.
That's right. All right, so we're given an address with no mask, and we want to turn this into 19 subnets that have at least 1,600 hosts per. We got to make sure it's possible if we do so. Now, this is really just doing powers of 2. This is a what class address by default?
That B?
It's a B. And they don't give it to you because that's another little thing that can be tested to make sure you start off right. So a B by default is a /16. The first 2 octets are your network
So
address.
if they don't give you a slash notation, you need to...
Step 1.
And if you screw that up, you're pretty well screwed.
Yeah, because your new subnet mask will be off if you went off something else. All right, so now what I've got to do is let's start with this first. We'll start with this 19. 2 to what power gives me something greater than or equal to 19?
32.
Yeah. So 2 to the 5th will actually equal 32, which works great. If I did 2 to the 4th, 1 less, that's only 16. That's not enough. Now, because we're doing static link subnet mask, where all the networks are the same size, yes, we're going to have some waste here. We got a little extra. It's all right, but basically 5 bits will have to be borrowed from the host portion to give me those subnets. And this is where you got to do a little bit of calculation, because it may be that you don't even have to do the problem. Let's take a look. If I currently have 16 bits in my subnet mask, and I add the 5 bits that I'm going to borrow to create my subnets, that equals a 21. Do I have enough bits left in the host portion to have at least 1,600 hosts in place? So how do I figure out that? Well, it's a 32-bit address. I'm taking 21 bits for the network, which is going to leave me with 11 bits. 2 to that power minus 2 equals 2,046. So I'm okay. It will work. If I would have borrowed 1 more bit, like if I had to make 35 subnets, I wouldn't have had enough space left on each one of those subnets to be able to address 1,600 hosts. Because then I would have been 2 to the 10th or less.
Forgetting the host for a moment, you got to the 21.
That's the new subnet mask, by the way.
That's the new subnet mask that gives you at least 19 subnets.
Yeah.
Okay.
Actually, it will give
So
you
if the question
32.
didn't have hosts in it, you'd be able to stop at that.
Yeah, and I'd be able to say, hey, my new subnet mask will be a /21, and they may ask for that, and it's not a decimal form, which would be 255.255. And there's my first 16 bits, so I got 5 more bits here, which means I got a 248. So that's the new subnet mask.